We're live. Here we go. Okay, we did this yesterday. This first page, you could probably fill it out on your own. So we're going to go fast. 10 to the second power, that's 10 times 10, or a 1 with 2 zeros. So 10 to the third would be 10 times 10 times 10, or a 1 with 3 zeros. Oh my goodness. 1, 2, 3, 4 zeros. 10 to the fifth is 10 times 10 times 10 times 10 times 10. Or one with 5 zeros. What's that? 1, 2, 3, 4, 5, 6. 7, 3. 4, 7, 4 minus 1. I'm done with my brain today. So, we now know that 10 to any number is a 1 with that number of zeros. If we take that 10 to a power and multiply by another whole number, we change out that 1 to that whole number. And you're like, holy cow, that sounds really confusing. Well, if we had done, let's say we've done 8 times 1,000, that's 8 times 1, 8, slap on the 3 zeros. That's all we're doing by multiplying by powers of 10. Okay, so 10 times 2 to the second power is 2 times 100, or 200. 3 times 10 to the third is 3 times a 1 with 3 zeros. And we know that 3 times 1 is 3, and then we just slap on 3 zeros. 4 times 10 to the fourth is just 4 times 1 with how many zeros? 4. We now know that 4 times 1 is still 4, and then we slap on the 4 zeros. This becomes 6 times 1 with 5 zeros. Or 6 times 1 is just 6 with the 5 zeros. Do you see how repetitive this is? It's counting zeros and then multiplying by the 1. Eight times 10 to the sixth, or 6 zeros. Whoops, it's an 8 with 6 zeros.
Jeez, DOS.
Now, yeah, it's an 8. Now, taking everything on the left side here, this is what we call scientific notation. And if you look at the top of the page, that's what our lesson is titled, Scientific Notation. That's a fancy way of saying we're going to take a number times 10 to a power to talk about really big numbers. Think about if you're going to count the stars in the universe. Millions? Billions? Trillions? I don't know. But it's going to become a number so big, and so instead of writing 8 million, 8 billion, 8 trillion every single time, they can just write 8 times 10 to whatever power they need. So it's just a way of shortening bigger numbers that they're going to need. Or if we're going to talk about blood cells in the human body. A lot. We don't want to write 20 zeros every single time we deal with those numbers. So scientific notation is a way to shorten that and add the zeros in a condensed version. All right, let's go down. Yes. The useful way of writing large or small numbers. What's that? Oh, man. Heroes, I thought I did it. Sorry, okay. So here they give it to us in Scientific. Holy shnikes, sorry. We're going to put it in standard. What does standard mean?
Like you go like 10 times 10 times 10 times 10 equals that.
No, that's expanded.
So
We're going to solve it. Okay, we know that this is a 1 with 3 zeros. So we could do 5 times 1 and slap on those 3 zeros.
yeah.
We know this is 10 to the second power is a 1 with 2 zeros is 100. Times 7 is a 7 with 2 zeros. Two times 10 to the 4th is a 2 with how many zeros?
4.
There we go. 5 times 10 to the 6th is a 5 with
6 zeros.
6 zeros. Number and word notation. It is read as 4 times 10 to the 3rd power. If you can say 5 times 10 to the 3rd power, 7 times 10 to the 2nd power. Somebody read that one for me. Noah.
2 times 10 to the 4th power.
Perfect. Who's got the last one? McKinley.
5 times 10 to the 6th power.
Perfect. You just did number and word. We're not going to write them all. All right?
Yep.
Okay. Next page. Look at that. We're cruising.
No, not cruising on a boat.
Okay. We're just going to go down here. We're going to keep moving. Event. The earth was formed. The first signs of life appeared. Fish appeared. Forest swamps, insects, and reptiles appeared. They're estimating the time of how long ago it happened. Okay? So instead of writing 2.5 times 10 to the 8, so moving that decimal 8 times, they're going to shorten it and write it in scientific notation. It's a lot easier to read and look at and to write over and over and over. Is that all they want us to do? Look at that. So we're going to need this on the next page. Do you guys have to flip back and forth?
Yeah.
Work with a partner. I'm your partner. We're all partners. So we could fill these in. According to the estimates by scientists, about how many years passed from the formation of the earth until the first signs of life? So we've got to use that chart on the last page. We're going to flip back and forth and fill this in. First thing that happened, they said, was 5 times 10 to the what?
9.
9. So we need how many zeros? How many?
9.
So we're going to put 1, 2, 3, 6, 7, 8, 9. What number goes here?
5.
Perfect. What's the second thing that happened?
The bacteria cells appeared.
Okay, so it's, what was our scientific notation, Allie?
4 times 10
To the 9th? Oh, cool. So we already know that 10 to the 9th starts there. And you said 4? Okay, thank you. I'm sorry. Cool. How long was the next thing, McKinley?
4 times 10 to the 8th.
All right, so 10 to the 8th. We'll start with our 4. And then 1, 2, 3, 4, 5, 6, 7, 8. What is a 0? Come on. What's the next thing that happens? Keep on going, Samantha. 3 times 10 to the 8th. I've only done 4 of these and I'm getting tired of writing this many zeros, right? That's why we're thankful for the scientific notation. Jillian, what's next? 2.5?
Yep.
So what do we do?
We could put it into a fraction
Can't put it into a fraction. Well, we can't just change the years.
We could put it for 2.5.
Let me ask you this. This is one place value, right?
Yep.
Miss Peterchick, please dial 100. Miss Peterchick, please dial 100.
So how many numbers can we have in this place value? 1. What's our first number?
2.
Let's go to the next thing. What was our next number?
5.
I'm going to prove to you why that works. Here, this was 5 times 10 to the 9th, correct?
Yep.
Would you agree that in that 5, that's rough to see, 5 times 10 to the 9th, would you agree that that's the same number?
Yep.
Would you agree that that's the same number?
Mr. Dawson, Henry's here.
Hi, Henry. Oh, I stole your desk. You can sit in Brecken's desk for today.
Which book is that?
Math book. So, what we really did, we said we're adding 9 zeros. Yes and no. We have to add 9 zeros because when we multiply by a multiple of 10, what we're actually doing is we're taking that decimal and moving it. Okay? So if we're going to take this and we say, oh, we add 9 zeros, what we really did is we went 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have to fill those in with zeros. So when we have 2.5 times 10 to the 8th, what we're really doing with 2.5, 1, 2, 3, 4, 5, 6, 7, 8. And we have to fill in the rest with decimals. Okay, so when we see times 10 to a certain number, we're really moving a decimal, which is important when we get to scientific notation because as you do scientific notation, as you get older in science, in math classes, it will be decimals. So you got to remember it's moving a decimal that many times. Okay? So, that being said, we'll keep going. Maybe. Oh, that was easier than yesterday. Feeling good. What's our next number? Lily.
1 times 10 to the 8th power.
1 times 10 to the 8th. So this one was a whole number with a decimal, and we moved it 2, 3, 4, 5, 6, 7, 8, and had to fill in with decimals. What's our next number? Quinn? Number 7.
Dinosaurs became extinct 6.5 times 10 to the 7th power.
6.5. So we moved that decimal 7 times. So we've got 6.5. 1, 2, 3, all the way to the end. So we're still filling in with zeros, except one of them is a 5, because that's the number they gave us. We don't just get to add 5s when we want. They gave us a 5. Zoe. See that? What was the first number? I missed it. 6 times
10 to the 6th.
to the 6th. 6, 1, 2, 3, 4, 5, 6. 2 left. Anybody going? Anybody not gotten a chance want to? Chris? Number 9.
Number 9.
He's got it. Times 10 to the what, bud?
10 to the 5.
So 8 times 10 to the 5th power. 1, 2, 3, 4, 5. And our last one, anybody have a chance yet? Zakia.
2 times 10 to the 4th power.
2 times 10 to the 4th power.
Four.
Okay, there we go. I gotta erase mine and go down, but yours will still be there, obviously, thankfully. According to the estimates by scientists, about how many years pass from the formation of the Earth until the first signs of life? So if you look back on the last page, what numbers are the Earth was formed and the first signs of life appeared?
The first signs of life, bacteria, substitute, 4 times 10 to the 9th power.
Okay, so if you flip back to the page with all the zeros, we're looking at 1 and 2. Okay, 1 and 2. They're both times 10 to the 9th, correct? So they have the same number of zeros. All the place values are going to line up. And it's going to be 0 minus 0, 0 minus 0, 9 times until we get to 5 take away 4. What's left over? 1, and how many zeros were still behind it? So we would say that would be 1 times 10 to the what? 9. Beautiful. About how many years passed between the appearance of the first fish and the appearance of forests and swamps? Do they have the same power of 10?
Yeah.
Sweet! So we just get to subtract the whole numbers out front, which is fine.
And it's 1 times 10 over 10 to the 8th power.
Good, well said. Also, these are word problems, so I need to add a what? That's my fault.
You need to add
1 times 10 to the 9th what?
the first signs of life.
They want to know how many years. According to the... What's that?
Next one is the appearance of fish, right? Never mind.
According to the geological record, about how long did dinosaurs roam the earth?
It doesn't really, 100 years.
Nope. Noah?
It doesn't really say. 2.5 to the 10 to the 8th power. 2.5 times 10.
So the first dinosaurs appeared 2.5 times 10 to the 8th. Then we got to go down to dinosaurs became extinct.
But they don't both got the same power.
You're right, they don't. If you look on your 215, 216, we can just pretend that these are a subtraction problem and then just subtract. Okay? So it's 2.5 times 10 to the what?
5.6. 2.5 times 10 to the 8th power.
Okay,
It's
so 8 minus 6.5 times 10 to the 7. So this is okay, these are all zeros. So really we've got 250 minus 65. 4, 10, 5, 18. 24 take away 6. How would we write that in scientific notation? Nuts. Scientific notation can only have a number with a decimal less than 10.
1 whole time.
I agree we need one whole.
8.5.
1.85 times 10 to the what? Do not count the zeros. Because remember, we moved a decimal. So if you were to pretend this decimal is right here, how many times Do we have to move it to get it out?
9.
8. Close. What years? Cool beans. Let's keep on.
Maybe I have it right here if you need it.
1.85 times 10 to the 8th. Gonzo. We are cruising. Okay, expanded form. This is where we take things and stretch it out. We're going to stretch these out by place value. Super duper. Here's an example. 4. 4 ones. That's just 4 times 1. I know. Woo! Well done. 8 tens. That's just 8 times 10. 7 hundreds is 7 times 100. 2 thousands is just 2 times 1,000. Think of it that way. 2,784. An expanded notation as an addition expression. A lot of mumbo jumbo in there. We know an expression means it's an equation without an equal sign. Addition means we're going to what? Add the different expanded notations. Somebody just tell me, what is 2,000? Because remember, we ignore the rest of it. This is in the thousands. What is 2,000 in expanded notation, Noah?
2 times 1,000.
Cool beans. So we're going to write in parentheses 2 times 1,000. All right, this one's done. And what are we going to do with each of these?
Add.
Add. What's our next place value?
7.
That's not the place value. That's the number in the place.
700.
In the hundreds. So that is 7 times 100. Plus, what's our next value?
8 times 10.
Oh, we did this wrong.
No.
Not really. We're just already ahead of them. We're doing this one. Well, that's fine. We'll flip it. See, they want multiplication expressions. We're doing the multiplication expression. That's fine. We're just ahead of them. 8 is in the what? Somebody already said it. I'm sorry.
10 times 80.
Not 10 times 80, just 8 times
10.
10. Plus, the 4 is in the
1.
ones. What they wanted us to do there is just good old-fashioned expanded form. So we'll do this. How's that?
Good.
Cool beans. Now we're going to write 2,784 in expanded notation as the sum of multiplication expressions using powers of 10. Ooh. Cool.
Oh, no.
Well, we know it's 2 times something. How do we write that as a power of 10?
10 to the 3rd power.
Marvelous. Plus. You see how Quinn did that? I'm sorry, I didn't mean to brush over that. 2 times 1,000 is 10 to the 3rd because there's 3 zeros. So 7 times 100 is 7 times 10 to the
2nd.
How many zeros?
2nd power.
2, so the 2nd power. Plus 8 times 10 to the
First power.
1st. Plus 4 times 10 to the... Don't overthink it. How many zeros do you see behind the 1?
1. So 1. 10 to the 1th power.
Do you see it was 0 right there?
No. 1.
No. How many? And this one?
0.
0. This is 10 to the 0. Ten to the 0 is just a 1 with 0 zeros. which is, I think, so silly, but that's how we have to keep it as a power of 10, is 10 to the 0. Okay, write 987 in expanded notation as an addition expression. So this is the one that I did wrong first. I told you wrong. We want it to look like this one here. Who wants to try it? We're just going to take it and break it up. Jillian?
900 plus 80 plus
Marvelous. Now we got to take 8,945 in expanding notation as the sum of multiplication expressions.
What?
Remember, that's the mumbo jumbo. The one that we did for A that I jumped ahead, that's what we're going to do for number 2. We know it's 8,000. 8,000 is 8 times what?
1,000.
So that's what you're going to do for each place. We know that it's 8,000, so 8 times 1,000 plus, Allie?
900 to 100.
Marvelous. Plus, Jillian?
4 times 10.
4 times 10. Plus, Jonathan?
5 times 1.
You. Absolutely marvelous. Cruising for a bruising.
Did the sum actually?
Right, 4,768 in expanded notation as the sum. Sum means
Add.
add. That's what we always do in expanded notation anyway. Of multiplication expressions using powers of 10.
Just do this one.
So we know that this is 4,000, which is 4 times 1,000, which in powers of 10 is 4 times. What
10
power
to
of
the third.
10 is 1,000?
10 to the 3rd.
10 to the 3rd, because 1,000 has 3 zeros. Okay? Plus 700. No?
7 to the 10. 7 times 10 to the 2nd power.
Nice. Good job. Plus. We're at 60, Smith. Did you want it or not? I'm sorry. You gonna try it? Yeah, to the 1st power. Super duper. Plus 8 times 10 to the
0 power.
That is a 0, but it looks like a dot. I apologize. That is a 0. That just means there's 0 zeros. What's that? Yeah. Isn't that great?
No, we have big brains.
Ready to rock and roll.
We have big brains.
Everybody got that one down?
And I got the 2nd one done.
What?
Yes. I got number 5 done.
Here we go.
Yeah, first time.
Here's what you're going to do. You're going to do number 5 on your own. Good luck. I'm going to pause this. Hello. Do you mind being on that?
No.
Okay, go ahead. I just need to ask. I forgot I'm supposed to ask.
I know you are being This one? No, number 8 is
I'm sorry, 5A. Yep. So this is just regular old expanded notation.
Our brains are longer. What? I didn't
What did you do?
I did it the other way.
That's
too.
perfect. You're fine. Keep going.
Can we just keep it, Doss, or do we have to erase it?
Make sure one of them look like this.
Just one?
So if you accidentally flipped it around, that's okay because I flipped it around up top. So that's perfect. Who's got letter B? Samantha. How's it look? Super duper? I agree. Go ahead. McKinley's got the last one. And they don't. What the heck? What are you going on over there? Sounds like a kid is being a pencil sharpener. Doesn't it? Maybe it's the actual pencil sharpener.
We're always quiet to them. How come they're never quiet to us?
Did you just say we're always quiet?
That is not.
I won't comment. I plead the fifth.
So do I.
The fifth, oddly enough, is to remain silent, no matter what. Perfect. 6 times 10 to the third, because 1,000 is a 1 with 3 zeros. So on down the line. How do we do? Feeling okay?
Yeah.
Expanded notation?
I did B for C and C for B.
Okay.
Math boxes.
Math boxes. Circle all the fractions that are equivalent to 3/8. 4 pages in a math box. So we got to figure out which one it is. How would we get 3 to 6? Times 2. What's 8 times 2? No, that ain't it. How do we get 3 to 9? What's 8 times 3? Woo! Okay. Can the reciprocal be equivalent to the fraction? No. Crazy humans. 3 times.
No.
No. How do we get 3 to 15? What's 8 times 5?
40.
Go. It's a real brow beater. Charlene has 2 5/8 yards of fabric. The curtain she is making requires 3 3/4 yards. How much more fabric does she need? She came up short. She needs more. How much more? So here's the 2 5/8. There's 3 3/4. How much is that? What do you need to do with that? Find the difference. Perfect. We need to take 3 3/4 minus 2 5/8.
Wouldn't it be 1 1/8?
It would be. Why?
Because you subtract it. It would be 1 1/8.
But this is 3/4. We can't do it as it is.
Choose 3/4 to 6/8.
6/8. Now we can subtract, which is 1/8. And the whole numbers is 1. So she needs 1 1/8 more what? Yards. Go. Since we just spent so much time on fractions and equivalent fractions, you can do that one on your own. Easy juice. The rule over here, what's my rule? 28 got put in and 7 got spit out. We can't just say 4. What did we do with 4?
Divide.
We divided because we got smaller, right? Because this is in, that's out. So we are going to divide by 4. 16 divided by 4. 1 divided by 4. You can do a fourth, or we know that's what is a decimal. You have 1/4 out of $1.
1.25.
0.25. Ah, nuts. They give us the out. We have to go backwards. So instead of dividing, we're going to
20.
and 0 divided by anything
Is 0.
is always 0.
I'm not wrong.
All right, this is a little peek ahead to what is coming. I'm excited. Order of operations. I love them. I love order of operations. It gets me excited. So, first thing that we always have to solve, if you ever see parentheses, you've got to do whatever's in there first. No matter what. That is always, always, always first. What is 16 divided by 2?
8.
I'm going to cross that out because our new problem is 32 divided by 8, which is 4. Isn't this easy when we know our facts? Uh-oh, it's the exact same problem, but they moved the parentheses. That shouldn't matter, Mr. Doss. 32 divided by 16?
4,
No.
8,
2. Oh, what's 2 divided by 2?
1.
Do you need to follow the order of operations? Yes. Okay. So we have to do both of these parentheses first. On nuts. I'll do 3 minus 1. You're welcome. Somebody help me with that one.
What?
6.5 plus 8.3. I need somebody. 14.8 divided by 2. Can 2 go into 1? No. Can 2 go into 14?
7 times.
No remainder, bring down the 8. How many times does 2 go into 8? Nothing left over. Cool. What do we do first? Times it. 4 times 12 is?
48.
Plus 8 is? These are going to be so fun.
I already have to break it.
Last one. Lilia did 2 3/4 hours of homework on Saturday. Rough. And 3/4 hour of homework on Sunday. Yup. What is the total time she spent on homework over the weekend? What are you going to do with those two numbers? Add them. Go ahead and finish up these math boxes if you're not already done. Jump to extra math. I will put the the IXLs on Google Classroom.
Easy, got easy.
Toodle.